Thank you. Hello, everyone. Welcome. Good morning. You saw the Mark 57 supersuit in Mark's talk just now, and he talked a little bit about the technology innovations that power the suit that help make Firefox 57 the best browser. I represent the Emerging Technology Organization, David Bryant, I'm a Mozilla Fellow, and what I wanted to do today is accomplish two things, really. One is to introduce you to the Emerging Technologies Organization, but also give you a little more detail into some of the technologies and the work that we've been doing that have found their way into Firefox 57 and other releases of Firefox, and which are also coming in the future to help you anticipate some new things that we can work on together as developers building for and on the web. So the Emerging Technologies Organization has its roots in Mozilla research. We heard a little bit about Mozilla research this morning. We're going to hear a little bit more about it in my talk and then later on in the day. And sort of the history of Mozilla research, and by the way, Mark and I didn't coordinate this, but I think this morning is going to turn into some sort of browser history class. So hopefully that's something that you're all going to enjoy. There will not be a quiz later, but we're going to cover a lot of history. So Emerging Technologies was originally Mozilla Research. Most of the work that we did in Mozilla Research was really focused on sort of the core technologies that power the web today. So the things that we have inside of Gecko, inside of Firefox, new future versions, JavaScript, other things. And so that history was really about making the existing web better and anticipating where the future of the web was going to go. About a year ago, we realized that we really needed to think a little bit more broadly than that. So we reframed our research organization as Emerging Technologies, and we gave it the mission to explore and identify new technology, product, and service areas that had impact and sustainability around which we could evolve and extend the web, and which could also serve as ways to make significant enhancements and improvements to strengthen our core business around Firefox. And so what I want to do is sort of talk you through some sort of history lessons that will give you a feel for the technologies, some of which are in Firefox today in 57, some are earlier or later, and which represent what we can all work on together as developers going forward. So the first story Mark actually gave you a bit of a preview of, and I'll move through this one pretty quickly. It starts in 2009 when Mozilla began work on a programming language we called Rust. And the motivating factor behind building a new programming language, because in the face of it, that doesn't really sound like something that you think a browser company would do, was a simple phrase, fearless concurrency. Wouldn't surprise you, I don't think, to find that Firefox is somewhere over 6 million lines of code, C and C++. We learned a lot from building, maintaining, and extending that large and complicated piece of system software. And it occurred to us that we were at a point in the evolution of the platform and the technologies where a new programming language could help us solve two problems. The fearless part was overcoming some of the limitations that we saw in languages like C and C++ in terms of managing memory and helping make our applications more robust, especially out in the hands of end users who are going to do all sorts of interesting things with them browsing the web. And concurrency, because we saw an evolution happening in hardware, not only the hardware in our computers and our laptops and our tablets, but in our mobile phones, to a world where the CPU in your computing device was a very powerful multi-core CPU. And if we were going to take full advantage of those technologies, of those CPUs, we needed to make it much easier for software developers, you've tried this, you know what I mean, to parallelize their applications and their code. And in doing so, the programming language could help not only make the code more robust, but it could help us do a much better job of taking advantage of the programming, of the hardware underneath in the systems and in your mobile phones. So Rust programming language, fearless concurrency, work progressed on the language, and then in 2012, there was enough of the language in place for us to launch a companion project called Servo. And Servo's motivation was to build a modern, highly performing web browser engine, taking advantage of the benefits of Rust, and to do so in a way, as Mark described, as kind of a workbench, where we could step back, take the benefits of the Rust programming language, look at the algorithms and internal subsystem components that we had already built out in Gecko and which were needed to power the web, and think about new ways to re-architect and re-implement them taking advantage of Rust's parallelization in particular. We could come back and look at each piece of the browser in light of better parallelization and better hardware utilization. Not only could we produce a more performant end-user experience, but we could also produce a browser that was better able to utilize the underlying hardware, which means it would be more useful on mobile, greater battery life, probably wouldn't get so hot in your hand while you were using it to browse the web. And so, as I said before, work on Servo began in 2012, revisiting many of the core subsystems and elements in Gecko and in Firefox. Fast forward now to about this time last year. We'd seen enough of the benefits of Rust. We demonstrated the advantages that we had in Servo. And we announced Project Quantum, which Mark referred to as an effort to broadly bring substantial improvements in performance and responsiveness to Firefox, knowing that speed is a thing that users always value above all in their browsing experience. And so here you see the history then. Rust led to Servo. Servo allowed us to build subsystems that took advantage of the Rust programming language. Quantum CSS, which you're going to hear a lot more about later today, shows you in detail how that technological evolution, rooted in Mozilla research and emerging technologies, finds its way into the product to make Firefox more awesome. So that's a story I think you probably maybe heard of. You're going to hear a little more about. I'll tell you another story and history lesson about something that we're also going to talk a little bit about today, but you may have heard less about otherwise in thinking about what's happening in Firefox. And that's to talk about WebAssembly. So for the history lesson part, around 2008 to 2010 was a period in the evolution of browsers which some people have called the JavaScript performance wars. This was a period of time where browser makers had come to understand that the end-user experience in the browser and interacting with web content was often determined by the performance and the speed of the underlying JavaScript engine. JavaScript's over 20 years old. In this window in 2008 to 2010, there was a vigorous effort to substantially improve the performance and execution of JavaScript in the browser. For example, through introducing just-in-time compilation and other sort of dynamic improvements in handling the code. Now, there are a couple interesting qualities of JavaScript that make that kind of thing challenging. One is JavaScript it's a programming language. It's designed for humans to actually see, read, program in, and maintain. And it's downloaded into the browser and processed when the user goes to the web page. So you've got ever increasingly large collections of JavaScript as assets in your web page or in your web application. The first chance the browser really gets to do anything about them is when the user navigates to the page and is waiting for something to actually happen. So there's really only so much you can do with JavaScript to improve the performance and the execution in the engine in that kind of an environment. But it caused us in research to think about other ways of looking at JavaScript and taking advantage of the technology. So instead of thinking about JavaScript as a language that humans program in, that represents sort of the source language for your web content or application, and then having an interpreter in the browser execute it, what if we thought of JavaScript as an intermediate language? It was simply used to communicate to the browser what was needed to happen in the program, and in doing so allowed us to take advantage of optimizations that we could do ahead of time in processing the source for the web application and not make the browser have to do them the minute the user loaded the web page. There were some other ideas that resulted from that line of thinking, which is we really didn't have to support everything in the JavaScript programming language. And the end result of this thinking was something called asm.js, which is effectively a subset of the JavaScript language that could be used as an intermediate representation in web applications and programs and allow us to move much of the optimization work ahead of time, upstream, and in fact support other programming languages besides JavaScript. So asm.js, another advantage I forgot of asm.js is it's JavaScript. So the JavaScript interpreter is already in the browser, and it's possible to take this more performant subset of JavaScript, deliver it into the browser, and have the browser take advantage of it without having to add new features and support to the browser. So every browser already in the world already supported JavaScript for the most part. It was easy for us to then deploy web applications and pages based on asm.js. And that worked remarkably well. It worked so well that, in fact, it motivated even crazier thinking within the JavaScript community and within research, is what if we went even one step further? What if the payload that was delivered to the browser to be executed wasn't even a subset of JavaScript? It wasn't necessarily even something a human could read, but was instead a binary representation, a compiled binary representation of the source application. And then we could get a lot of other benefits. Faster parsing, faster loading, other advantages that I'll talk about on the next slide. And that led to WebAssembly. And one of the differences of WebAssembly is that we needed it to be a standard. If we were going to add WebAssembly support to the browsers, we needed the other browser vendors to agree that it was a good idea. And this was a place where asm.js actually made a significant difference as well. The success of asm.js motivated other browser vendors not only to be comfortable adopting WebAssembly, but to abandon some of the work that they had been doing to produce alternative technologies and rally around WebAssembly, develop it as a standard, and ship it. And we, in fact, Firefox was the first browser to support WebAssembly in Firefox 52 in March of this past year. So, to recap, WebAssembly is a virtual CPU in your browser. So what we've done is we've taken the JavaScript engine and the use of the JavaScript programming language, which you can still do as a developer. Happy to have you write programs in JavaScript and deploy them into the browser. I do. But we also now have a code path that allows us to take a lot more complicated algorithms, content. If you're thinking about making a web game where you have a lot of sophisticated assets and a lot of algorithms and code that need to be compiled and executed and loaded into the application, WebAssembly gives you a much more powerful way to actually do that, and in fact, it opens up the use of other programming languages as this overall source language. So WebAssembly is capable of compiling other languages, C, for example, C++, into this virtual CPU, virtual instruction set binary form, and loading it into the browser. So that's the history. Let me talk a little bit more about what it looks like and how it works. So you'll see diagrammatically here, we have the source languages. Currently we support a variety of them, but not every major programming language, and I'll talk about why that is in a minute. This is all done on your desktop machine. The tool chain can actually compile those languages and aggressively optimize them, doing things to optimize them that we couldn't actually do in optimizing JavaScript inside the browser engine. And produces the binary module associated with WebAssembly. The WebAssembly module just becomes then an asset associated with your web application, just like JavaScript code or CSS files or whatever. And when the browser goes to download your web application, it pulls the WebAssembly module down. Doesn't have to parse it, doesn't have to figure out what's going on, doesn't have to optimize it. It can just load it up and go. So what you end up getting through this virtual CPU in the browser with WebAssembly is effectively JavaScript execution at near native speeds. One of the other advantages of WebAssembly is it means that we're now to the point where anything you'd really need to do in your web application, you can actually do just using the web technologies that are supported in the browser. For much of the history of browsers, we recognized the need for this concept called plugins, which opened a little hole in the execution environment in the browser and allowed you to plug in native elements, libraries, or whatnot. And the browser would delegate some of the execution to those native elements. With WebAssembly, we provided enough technology and enough power in the browser engine to no longer have the need for those plugins. One of the substantial benefits of that is we've been able to deprecate all of the plugins that were in use on the web, most notably Flash. And so one of the indirect benefits of WebAssembly and supporting WebAssembly in the browser is that we no longer need to support Flash as a plugin. And you can, as you have heard probably, Flash is now not being supported actively, or there's plans to not support it actively in every browser, and the technology will be retired. As I mentioned before, WebAssembly is a W3C standard. It's supported by all browsers. I'm sometimes asked sort of how successful has WebAssembly been? Data we have today indicates that about 58% of the browsers deployed in the world have support for them in WebAssembly today, and that's a pretty good number. But that number is going to go up substantially because 2 of the major browser vendors don't yet actually support WebAssembly. Apple's support for WebAssembly is coming in Safari 11, which is shipping this week, approximately, depending on which target device you may have. Microsoft also doesn't yet support WebAssembly in Edge, but support for it is coming through the Windows Creators Update next month. So we're at 60% penetration of WebAssembly in browsers today. Without Microsoft and Apple's participation, that number is only going to go up rapidly. And that will help you maybe understand why many of the web game developers and web application developers that we've been working with have been so excited about embracing and adopting WebAssembly. Oh, another question I get asked about WebAssembly is, great, so what's coming next? Is WebAssembly sort of done? Do we have all the WebAssembly features we're ever going to have? The answer is no. The initial implementation that we support in Firefox and that is being supported in other browsers is really the first generation of WebAssembly. And there are a number of things that we're working on to improve WebAssembly, both as a virtual CPU, but also the developer experience around WebAssembly. So for example, the next version of WebAssembly is going to allow us to support more programming languages. In particular today, programming languages that are predicated on their own internal garbage collector can't readily be compiled and run in WebAssembly. And so garbage collection support between the languages and the virtual CPU is a feature that we're working on aggressively for WebAssembly. Also, WebAssembly today still has a little bit of a serious set of limitations in terms of the ability of code in WebAssembly to interact with the DOM and the rest of the web page. And so there's work to enhance what can be done sort of across that WebAssembly JavaScript boundary and in working with the DOM and the web page to give web developers more power to use WebAssembly to create web experiences. And lastly, there's work on developer tooling. So in present form, debugging WebAssembly is kind of an interesting challenge. I'm old enough and have been programming long enough to have programmed in assembler language many years ago and dealt with debugging assembler language code, and debugging WebAssembly is not all that much easier. And it's challenging, and so we're looking forward to improving the tool chain support for WebAssembly, in particular in debugging, but in other areas as well. And so as I mentioned, WebAssembly shipped in Firefox 52. It's out there. Love to talk to people who are interested in taking advantage of WebAssembly. One of the interesting side benefits of WebAssembly is that you might be able you would benefit from it as a developer or an end user without actually using it directly. And that's because tool chains and JavaScript frameworks can take advantage of WebAssembly. And you'll get those benefits when they do without noticing any particular change to those tool chains or those web frameworks. So we expect to see substantial improvements in the quality of the web experience and the performance of the web experience with WebAssembly for you as developers, even though you don't have to take advantage of it if you don't want to. But if you're interested, we'd certainly love to talk to you about how you can do that. All right. Another set of, as I mentioned before, in emerging technologies, we're about exploring new kinds of experiences on the web and building the technologies, proving out the technologies to make them available to you and to make them happen. And so I'm going to talk about a couple of examples of that that are also involved with Firefox, supported in Firefox in one way or another. And these are maybe some things that you haven't thought about us working on, but we'd love to explain them more and get you more involved. So one is virtual reality. I'm sure you've all heard about virtual reality. A question I always like to ask in situations like this is whether or not you've had a VR headset on. If you've not, then that's a homework assignment that I want you to actually go take advantage of. And in fact, out in the lobby, we're set up, I think, to help you take care of that. You really can't have a sense for what VR is like until you've had a headset on and have had an opportunity to experience it. WebVR is extending the web API paradigm to make it easy for you to build web content that actually can be rendered in virtual reality. So it provides a set of JavaScript APIs that you can use to recognize and interact with the headset, which is essentially another kind of display, with the sensors that are mounted in the headset or in satellites deployed around the room, which is what's used to determine where the user is, which way they're facing, that sort of thing. And then these days with the controllers. because it's a lot more fun to play a game in VR when you can actually wield the sword or open the safe using the controllers that are part of the VR system. So with Web API, which is a W3 standard, you can actually use your existing web developer skills to create additional JavaScript elements that will let you extend the web experiences that you're building today to deliver and render them in VR. Either because you like the idea of virtual reality, or you like the idea of rendering your application in a virtual space. So for example, a popular thing to do in VR is watch video. 360 videos and experience sort of virtually other places in the world. That's a relatively easy thing to do thanks to the WebVR API. It is a standard. We shipped support for WebVR 1.1 in Firefox 55 earlier this summer. If you haven't had a chance to play with WebVR, trying to build something with it is an easy thing to do. I recommend you give it a shot. An easy way to do that, as sort of as a companion technology that we've also produced through our efforts in emerging technologies and with the Firefox team and others, is something we call A-Frame. And if you think about WebVR as the set of APIs that you need to sort of integrate with and interact with the headset and the controls and the user's environment, you're still faced with the challenge of how do I build the virtual world that I want people to be able to experience. And A-Frame is a technology that lets us do that. A-Frame takes the existing familiar HTML syntax and document model and extends it with a set of tags that you can use to actually build out and create virtual scenes. Simple things. I built an X-Wing, for example, with A-Frame. It was a lot of fun. But you can build whole environments with A-Frame, again, leveraging the expertise and the knowledge and the tools that you already have as a web developer just from building HTML documents and associating them with JavaScript. A-Frame is also open and implemented on the web. You'll see demos of A-Frame outside, and you can build your own worlds and get going with A-Frame. We're starting to see, in fact, widespread use of A-Frame. It's fairly popular as a framework for building virtual reality experiences, not only from sort of game makers and other creative types, but we're seeing major publications put information online and create experiences for magazine or newspaper readers. As a VR kind of thing, you can sort of walk around on the surface of Mars, for example, due to an effort from the Washington Post. And that's possible because they've taken their web development skills and just moved quickly into the use of A-Frame to build them and deploy them on the web. But so far, everything I've told you has been about virtual reality, which is kind of the more exotic but self-contained version of the problem, because everything that goes with virtual reality is just what you've built and put into the virtual world. Another increasingly popular form of not real reality is augmented reality. Something we've heard about from vendors, Apple, Google, others have begun publishing toolkits to let you take your mobile phone in particular and the camera in your mobile phone and begin to build augmented reality experiences. So if you like those little creatures that we have in Firefox, you can actually easily build an augmented reality application that will let you animate them in the world around you and see them in looking through the camera on your phone. If you think about augmented reality as kind of one end of a spectrum and virtual reality as the other, sort of collectively there's a class of experiences which have come to be called mixed reality. So mixed reality is intermixing augmented reality concepts and virtual reality concepts to kind of let the web developer build whatever it is you want to build. And the good news from our perspective is that mixed reality, the mixture of VR and AR, is possible and easy as an extension of the WebVR APIs and A-Frame as a toolkit. So just like A-Frame and WebVR make it easier for you as a web developer to build virtual reality experiences, with mixed reality, by extending A-Frame and VR, we're going to let you be able to use your web development expertise to build all sorts of mixed and augmented reality kind of things and deploy them on the web and get all of the benefits of the web that you're already familiar with and know and love. Another completely different kind of web experience that we're actively pursuing developing in emerging technology is speech. A lot of interest these days in being able to interact with applications and services by talking to them. Unfortunately, the history of speech technology is not one that's particularly open and accessible to everyone. A lot of that technology is the results of many years of research in their proprietary and closed ecosystems. So we announced a project in emerging technologies called Deep Speech, which is designed to build a completely open source speech engine comparable to the closed commercial systems that you find today in your phone or in your Amazon Echo, and make that available to web developers as well. So if you'd like to put a speech interface on your web application or build your application in such a way that you can incorporate speech-based interaction with the user, we're building in Deep Speech an open source engine that will let you do that. And the code is on GitHub if you'd like to check it out. One of the interesting things about building a speech recognition engine is if you just built the engine, it actually does a terrible job recognizing speech. And that's because you need to train the engine. The closed proprietary speech systems work because they've accumulated petabytes of voice data that they can use to train and enhance their classifier. So a companion project that we've announced in emerging technologies, which you'll also see demonstrated outside, is Common Voice. Common Voice lets any and all of us contribute our voice to this open data set that we're building as a companion to our deep speech engine to make it easy for people to build across multiple languages speech recognition in an open and transparent way. And with the Common Voice, you can either say things and have us record them, you talk to your browser and we'll record them, or we'll actually let you listen to what other people have said and you can validate that they actually said what we asked them to say. So between Deep Speech and Common Voice, we believe we can put a complete and powerful speech recognition experience in place on the web, and you can take advantage of that as a web developer and deliver it as well. So to wrap up, I created hopefully some areas to spark your interest and maybe some homework assignments. One is to, if you're interested in VR, to take a look at A-Frame and WebVR. If you got a headset, that's great, and you can try one out outside. If not, you can actually do this on a regular desktop browser or on your mobile phone. Voice Fill, which I didn't talk much about, is a test pilot experiment that we've deployed in Firefox that integrates our deep speech engine with the browser. And what Voice Fill lets you do, if you'd like to add it to Firefox through test pilot, is you can do searches with a number of popular web search engines by talking to your browser. And I know you've all wanted to do that. You probably already talk to your browser. Now you can actually talk to your browser and it will do what you tell it to do. So with the Voice Fill add-in, you click a little microphone button, that's the button there. The search field actually becomes speech enabled and you can just tell the browser what you want. It will translate your spoken word into text, inject that into the search and give you back the results. So try it out. Project Common Voice, please leave us your samples. We were originally supporting English, but we've added more languages to Common Voice to make that possible. And then as Mark mentioned, as web developers, you can get out and build a web extension. So between web extensions and WebAssembly, if there's some feature you've wanted to add to the browser, we've given you the tools to make that fairly straightforward for you to do using the expertise that you already have as web developers. And of course, this is my last slide. Thank you for your attention. And I will remind you, as Mark did, download Firefox nightly, get Firefox 57 and tell your friends. And as a developer, also pick up the developer edition because you're going to get the same advanced technologies and components that we put in Firefox 57. So happy to see you and answer questions later. Thank you.
Thank you, David. Thanks for so specific information, right?